Hi everyone, welcome to your unit or your lesson rather, on alpha particle radiation. So I've talked before about how this unit is going to be all about the atomic bomb and how scientists were responsible for creating this horrific, huge weapon called the atomic bomb. And one of the things that makes atomic bombs and nuclear bombs so dangerous and so deadly is that they're radioactive. And what radioactive means is that they release radiation. And so it's important that you understand what radiation is. Now, there are lots of different types of radiation. Today, we're going to be talking specifically about a type of radiation called alpha particle radiation. And later, we'll learn about other types of radiation as well. So the goal today is to understand how alpha radiation works. What's happening when an atom is releasing alpha radiation? Well, let's start with radiation in general. Radiation, the definition I have up here, is that radiation is when an object releases energy, which travels through space, and is then absorbed by a second object. Now, that's a pretty vague definition because, well, radiation can be a lot of different things. So, for example, here's the sun. It's a beautiful day. My drawing isn't so beautiful. Here's me out catching some rays. Now, those rays of light, UV light, color, that kind of give me a nice warm feeling on my skin and a nice tan, those are radiation. Those are waves of energy that are released from one object, released from the sun. They travel through space, and then they're absorbed by the second object. And I'm the second object, right? I'm absorbing that radiation into my skin. Now, this is an example of a type of radiation that's a wave. We talked about waves of light. But radiation can also come in the form of tiny little particles, kind of like little atoms that get shot out from one object. And that's the type of radiation we're going to talk about today. So again, today we're talking about a type of radiation called alpha radiation. Now, the strange little symbol that you see over here that kind of looks like a funny looking A, that's the Greek letter alpha. So that's the symbol we use to represent alpha radiation. So what is alpha radiation? Alpha radiation is a little particle. We talk about alpha particles. And it's made up of 2 protons and 2 neutrons. Now, you should remember from our previous unit that both protons and neutrons are found inside the nucleus. So when I say an atom is emitting alpha particles, I'm going to use that word a lot in this unit. To emit means to let off. So when an atom is emitting alpha particles, it's basically shooting a little group that's 2 protons and 2 neutrons out from inside of its nucleus. So right here, you have a diagram of exactly that. So we call this alpha decay. That's the same thing as alpha radiation, no different. So here I have the atom plutonium. Pu is the element plutonium. And it's going to emit an alpha particle. And when it does that, it actually turns into a new element. It turns into uranium. So to understand why that happens, we need to rewind a little bit and remember some of the stuff you learned earlier in the year about the structure of an atom. So Pu, I said, is plutonium. And its mass number is 240. And its atomic number is 94. So what that means is that the atomic number tells us the number of protons. So that tells us that plutonium has 94 protons. And the mass is just the total number of protons and neutrons put together. So it has a total of 240 protons and neutrons. Right? And again, remember that the number of protons is what defines the element. What I mean by that is that plutonium is plutonium because of the fact that it has 94 protons. If I change the protons, I change the element. So how come it turns into uranium? Well, let's think about an alpha particle. We learned that alpha particles are 2 protons plus 2 neutrons. So this is how I write an alpha particle. 2 on the bottom means that it has 2 protons. And the 4 on the top is just like up here. It's the mass number. It means that there are a total of 4 protons plus neutrons. So the total number of particles is 4, but the protons is 2. And that's just what we saw up here, right? 4 particles in total, 2 of them are protons. 4 particles in total, 2 of them are protons. So what happens to plutonium? Well, it has 94 protons to start with. But if it lets off an alpha particle, it's going to lose 2 of those protons. So if it loses 2 protons, it's left with 92. Now, up here is the mass number, 240. That means it's the total number of particles in the nucleus. Well, an alpha particle has a total of 4 particles inside of it. So if plutonium loses an alpha particle, that means it's losing 4 particles. So the mass number goes down to 236. So again, recap. The number of protons, the atomic number, goes from 94 to 92 because 2 protons leave with the alpha particle. The mass number goes from 240 to 236 because in total, 4 particles are lost. Now, remember how I said plutonium is only plutonium because it has 94 protons? Well, if it now has 92 protons, it's not plutonium anymore. So how do I know it's uranium? Well, I have to open up my periodic table and I have to look up the element that has atomic number 92. Now we've seen this before. The number of protons is what defines the element. So if this new element has 92 protons, I have to look up which element on the periodic table is number 92, and that's my new element. So alpha particle radiation is when some element is going to spontaneously release or eject or emit an alpha particle, which is 2 protons plus 2 neutrons, which gives us a total of 4 particles. And when it does that, it turns into a new element. Let's do another example. Here I have an element called bismuth, Bi. So ask yourself, how many protons are in bismuth? You should be able to figure out that there are 83 protons in bismuth, because that's what this number 83 down here means. It's the atomic number, the number of protons. And if you looked up Bi on the periodic table, you should find that it's number 83. So what's the mass number for bismuth? The mass number for bismuth is 209. And that means that there are 83 protons, but there are a total of 209 protons plus neutrons. So again, for bismuth, we've got 83 protons, but 209 total particles in the nucleus. So we're going to write this out just like we would write a chemical reaction, as a way of showing what happens when bismuth undergoes alpha radiation. So I'm going to draw an arrow. Okay. And I'm going to draw the alpha symbol on top. And that means that this is alpha radiation. So, well, first I know I'm going to produce an alpha particle. So that alpha particle has a mass of 4 and an atomic number of 2. And I write, instead of calling it there are a couple different ways you can do this. You can write A for alpha, or Greek letter alpha. There we go, that's a pretty alpha. Or you could write He. And the reason that you can also call this He is that helium is the element with an atomic number of 2. So an alpha particle in some ways is also just a helium nucleus. It's like bismuth is ejecting a helium. So what's left? What else do we get? So bismuth is going to release a helium, but that's not it. What's going to be left over? So if bismuth loses a total of 4 particles, its atomic mass is going to go from 209 to 205. Because 209 minus the 4 particles in the alpha particle is going to leave us with 209 particles inside the bismuth. Except for it's not going to be bismuth anymore. We've seen that as well. What's it going to be? Well, it's going to be whatever element has 2 fewer protons. So if bismuth has 83 protons, our new element will have 81. So in order to figure out what my new element is, I need to look it up on the periodic table. What do I look up? I look up atomic number 81. And what you should find is that the element with atomic number 81 is called thallium. It's Tl. All right, so let's recap. We have the element bismuth. It has 209 total particles. 83 of those are protons. It undergoes alpha radiation, which means it lets off an alpha particle, which has 2 protons, 2 neutrons, or a total of 4 particles. Here's my alpha particle. So bismuth is going to let off an alpha particle, and then it's not going to be bismuth anymore because it changed its number of protons. So what's left after bismuth sort of ejects or emits this alpha particle is 81 protons, which means that this is the element thallium, Tl. And because I lost a total of 4 particles, 4 protons and neutrons, the total mass of the element went from 209 to 205. Here's one more example. This is the element radium. It's got 88 protons and a mass number of 226. See if you can predict on your own what compound radium would form if it emits an alpha particle during radiation. And we'll go over the answer in class tomorrow. It's fine if you make a mistake, but I want you to give it a try on your own. So just to recap today's lesson, we talked about radiation. Radiation is when an object releases energy. That energy travels through space and is absorbed by a second object. That energy can be a wave, just like the sun rays giving me a nice tan, or it can be a particle. And today we looked at a type of particle radiation. We looked at alpha radiation. Alpha radiation is a tiny little blob of protons and neutrons. It's 2 protons and 2 neutrons glued together. And when an element undergoes alpha decay, what that means is that it lets off alpha radiation, it actually changes into a whole new element. And the reason for that is that the number of protons changes when the element lets off alpha radiation. We'll talk more about this in class tomorrow.